Welcome to my end of the semester screencast for Physics 111. My primary goal in this screencast is to make a case for why I deserve an A in this class. I want to start by saying that throughout the course I use the syllabus as my Bible to guide my projects. I completed everything on the rubric that was required for an A in the course, starting with using my notebook. On the screen here you see an example of my notebook. I used it to log my time spent on each activity. I logged the time and the date. Some cases I actually wrote the actual time if I was coming back to an activity. I spent overall around 157 hours, or an average of 21 hours a week in the course. I also completed all the assigned VPython programs. I did the spiral kinetics and spiral dynamics activities, learning the equations of velocity, acceleration, and net force. I read every article and responded to them, and responded in 8 to 8 different students, including ongoing dialogues in some cases. I wrote a controversial debate, debating both sides of the hydraulic fracturing phenomenon in this country. And I attended the Musical Instrument Museum for my cultural science, replied to all the controversial debates that others posted on. I also posted something to every neat resource for each week. And throughout the course I used problem-solving skills to find answers to most of the difficult questions myself, and actually posted a few times on the technical forum to help others. I created screencasts with written comments for every week, and overall I made connections between all the different topics and also between the different topics and my own life. All right, I'm going to go into each of those aspects in a little bit more detail. This, of course, shows the use of my notebook. I used my notebook also to complete homework assignments, which I will get to later. Here's an example of that. One of my favorite things in this course was learning how to apply the physics concepts learned to programming. So here was some of the highlights. This was the collision program that I wrote. This was the first time that I had significant challenges. I never gave up, and I finished to produce a working game. And here, all these lines of code are my elaborate scoring version. And I actually gave bonus points for each second under, I think it was, oh, here we go, under 60 seconds. If you hit all the balls before 60 seconds was up, you got bonus points for each one. Another highlight to Python was my Pong game, and I have the coding for that here. And I worked really hard on this game. I actually handed it in a little bit late, sadly, but I feel like I still deserve an A because by midnight I had it mostly finished and could have submitted, but there were a few details left undone that I wanted to be sure to get done. So I stayed up till 6 in the morning working continuously to make sure I could get the two colors. And in order to get the ball to collide with the paddle, I had to skip ahead to chapter 24 to see how to get that done. So I could get the ball to have an elastic collision with the paddle. And one side, it would shoot it out at the same exact speed. If you hit the other side, it would double the speed. So it was kind of fun doing that. I do plan to complete chapters 21 through 24, but after spending several hours in an attempt to get Tank Wars to work this morning, I decided I'm going to need more time beyond the end date of the course to do that optional work. I also enjoyed creating the lunar lander game and investigating the relationship between the net force over mass and the acceleration, and the concept of free fall caused by the force of gravity. Another activity that we did through the physics through video games was using the tracker program, and here was one of my favorite activities. I really liked how this showed how the vectors combine to create a trajectory. Here, this is just showing the y motion attributed to the force of gravity, and you see a constant acceleration because of the decreasing velocity. Here, this is one of the beauties of the tracker program. You can actually change it to show the x component, which is more or less a straight line because of the x motion used by his hand. I really like seeing how the graphs of motion give you immediate information on velocity and acceleration based on the shape, direction, and the line itself and the slope of that line. And I can use this knowledge of vectors to develop better baseball and basketball throws. As I was thinking about it, there is a point where your x direction is at a maximum where you can get, with a little bit of a curve, you can get actually a greater distance than if you throw it straight. Because if you throw it straight, you're lower and it kind of just goes down. So you want a little bit of curved trajectory to your throw to get maximum distance. I also completed all the assignments in the spiral kinematics book, and I was showing that earlier. I'll go back to that. In my notebook here, this is my tour de force for the class. I found it very interesting how you could use the motion diagram to help conceptualize the knowledge. For example, here, it seems like the motion is decelerating, but actually that's not what's happening. It's actually accelerating in the upward direction, and whether or not it's negative or positive depends on where you set up your coordinate system. So this helped me to solve the problems and get accurate answers, and helped me analyze my answers to make sure they made sense. The reason why I say this was my tour de force is because I had learned in the course how to use two equations, and I think those are shown on the next page. So I'm going to scroll ahead to that and then I'll come back. I learned how to use the two kinematic equations. Oh, here they are. Just scroll down a little bit too far. And the two equations involved velocity, taking velocity 2 and combining it with velocity 1 and acceleration in order to come up with. Here I was able to calculate the time. Taking the velocity of 0, I was able to come up with a time of 0.89 seconds when that cable would break using the force of over 40 newtons. And then I also used, to calculate the distance, I used the other equation by substituting in the value I calculated for the time. So then I was able to come up with a distance of 1.6 meters, distance the elevator would travel before that cable would break. But in order to do all this, I had to use the force equation that I learned, the new one that I had learned, to come up with the acceleration. And I had to plug in what I got here into this equation for the bottom light in order to come up with my acceleration. Another reason why I feel that I earned an A in this class, I responded to every article, and I'm going to go back to my windows down here for that. This was the value of creative disobedience, and not only did I, not only did I post my own thoughts, but I also posted to other students and creating a running dialogue in some cases. Here I was responding to Kendra's idea that she was getting discouraged that in so many cases she'd read all these articles in the different areas, Engage Me or Enrage Me, Students Today and Shift Happens, watching a TED Talk on boys and gaming, and she felt like she was coming across the same material over time and time again, but no one's making any changes. And I told her, actually, in the school district I work in, we have implemented a new math program to encourage just what this article is talking about. So that kind of helped her to feel better about everything we were learning about. Responding to all these different articles, here was Allie Chelman's engaging TED Talk talking about how boys learn better through video games. It reaches their brains better. And here, oh, this was controversial debates. I will come back to that in a little bit. But anyway, this posting to all these different articles and reading them really allowed me to reflect on how our society is changing and how I'll fit into the new order. I do believe there needs to be a balance, and certain social standards need to be maintained to keep an attitude of civility. And that really made me think of the Digital Nation video that we watched, all 9 segments of that, and how it really showed the benefits and problems with our current inundation with digital technology. How it can bring about educational reform, but it also can isolate people. So anyway, throughout the course, I posted 8 responses to everybody's ideas and continued brief dialogues on those. Okay, getting on to the controversial debates. I did my own controversial debate, and here is an example of one of the resources I used, where this man could light his water source on fire because of the natural gas being released into the water system as a result of hydraulic fracturing. And I connected this to Digital Nation because I started to wonder how in the future we may not need as many fossil fuels if we progress the way it was suggested. People can meet in the virtual world and work from home, so we won't need to use fossil fuels to run our cars because we won't need to drive anywhere. I read everyone else's debates and responded to those. I have an example here of that, where I responded to someone's debate on the Egyptians and the possibility that aliens helped them with that technology. I was able to learn something about topics as diverse as the efficacy of vaccines and homeopathy and energy bracelets, to different sources of energy, to some conspiracy theories surrounding chemtrails, the pyramids here that I responded to, and the controlled demolition of the World Trade Center, which has bothered me for many years, wondering how, once it started collapsing, how the whole thing just folded in on itself. It did seem like controlled demolition to me. I found that the students in their debates made light of many questions surrounding all these topics, and I learned the importance of conducting scientific tests using appropriate statistical techniques in order to ensure that the results show a significant change. So much evidence presented, it was just biased by the writer's opinions, and I felt the students did a great job seeking out the evidence, the scientific evidence. It was very telling how solid scientific studies were actually lacking in many of the cases. Also, other things I did to earn an A, I also, for my cultural science, attended the Musical Instrument Museum, and here's a nice picture of what that looks like. And I enjoyed learning about instruments such as the octabass, which is shown here. On the octabass, the lowest note, you can't even really hear the fundamental pitch. So that employed some of the physics concepts of how strings vibrate and how we perceive sound and how the mind plays into the actual bare physics as well. I also enjoyed finding neat resources every week. Here is my neat resource on collisions. I found some information on the Large Hadron Collider, which investigates how the Big Bang theory, or excuse me, how the Big Bang might have occurred, and how the speed of light is a barrier that can't be surpassed. I also discovered that same barrier in investigating relativity and how time is perceived differently when you're traveling close to the speed of light, or at any speed actually. Time slows down for you because they explained it as the properties of vectors, that you're actually traveling and you're not traveling at bare time anymore. You're traveling at a slower rate because you cannot breach the barrier of the speed of light. I also enjoyed posting on the lunar lander. One of the students did a controversial debate on whether or not the lunar landing was a hoax. And this shows how Neil Armstrong had to practice on the lunar lander on Earth, but he had to use a different machine that was designed to withstand Earth's atmosphere, because the actual lunar lander was designed for less gravity and also no wind. So in this example, Neil Armstrong had a little bit of a problem doing that. Overall, I believe that I earned an A because I learned how physics is an integral part of every aspect of our lives, from technology to throwing balls to making music and mining for fossil fuels. And I went above and beyond to make these different connections between the topics and to my own life. I did all the programming in the Python, kept track of my work in a notebook, learned about the two kinematic equations that can be used to solve any story problem in mechanics. I was able to apply the knowledge to my life as a first grade teacher and helping to motivate students and to teaching science. I learned about hydraulic fracturing. I attended the MIM and learned about the physics in making music, replied to all the controversial debates, posted to every neat resource, and throughout the course just used problem-solving skills in order to master most of the difficulties myself. And finally, I learned how to make a screencast. I'm still working on making a coherent screencast and being able to access the different pages throughout, but I feel like I made a lot of progress in that area. Thank you, and I hope that I have convinced you that I did, in fact, earn an A in this course.